Rochelle salt synthesis. Rochelle salt, or the UPAC name for it, potassium sodium tartrate tetrahydrate, is highly water soluble. It is a solid that will form large transparent prismatic crystals, and these crystals are very unique. They are piezoelectric between minus 18 degrees Celsius and 24 degrees Celsius. One of the recommended methods to prepare the Rochelle salt is to take cream of tartar, dissolve it in water, add sodium carbonate, also dissolved, and produce a saturated solution of Rochelle salt, which, if you let it slowly evaporate, will grow crystals of Rochelle salt. And then you will be ready to test that for piezoelectric behavior. A side product of this experiment is carbonic acid, which is a relatively unstable acid that easily decomposes into carbon dioxide and water. In order to prepare for our synthesis, we need some information. First, we need the mass of the cream of tartar crystals. And it's really a good idea to start with crystals of cream of tartar to make sure that you're not bringing in any impurities into the reaction. Next, because at the end you will not recover your solid right away, but you want to continue and produce your crystals in your saturated solution, you want to add only a stoichiometric amount of sodium carbonate. So you need to calculate this. Then you will need to determine the mass of the potassium sodium tartrate tetrahydrate, or Rochelle salt, that was formed in this experiment, because using the solubility of it, which is information piece number 4, you need to find the solubility of Rochelle salt at room temperature. This is a relatively easy literature search. And using this information, you will be able to determine information piece number 5. What volume of water do you need to dissolve the Rochelle salt that is produced? One thing to consider for this experiment is that the Rochelle salt is significantly more soluble in water than the cream of tartar. So one way to determine that your reaction is complete is noticing that all your cream of tartar disappeared or dissolved. Because first it will dissolve, and as it reacts, the dissolved amount is drawn away as a product, as Rochelle salt, and now it's able to dissolve more of the cream of tartar, and that will cause the reaction to proceed. So let's make sure that we add the correct amounts of everything. So at the end, the only crystals that form in our beaker are going to be the Rochelle salt crystals. So let's start with writing a balanced chemical equation, which we have here. We are going to use the stoichiometric ratios described in this equation and the mass of the cream of tartar that we crystallized earlier to determine how much sodium carbonate we need to add to this. And again, if we're adding sodium carbonate, it has to be pure sodium carbonate. Let's get started. We have 21.93 grams of cream of tartar, or potassium bitartrate. We're going to convert this into moles. So on top we'll say every 1 mole of the cream of tartar weighs 188 grams. And then we use the mole ratio from the equation. In order to proceed with the reaction, for every 2 moles of the potassium bitartrate, we will consume 1 mole of the sodium carbonate. But because we can't measure moles on a scale, we will convert our moles of sodium carbonate into grams. 1 mole of sodium carbonate weighs 106 grams of sodium carbonate. We will cancel the grams and the moles of the cream of tartar and the moles of the sodium carbonate in our calculation, and we can determine the mass of sodium carbonate in grams. We find that the value is 6.18 grams of sodium carbonate. So the setup now is fairly straightforward. We're going to add all our cream of tartar, which is the 21.93 grams, and the 6.18 grams of sodium carbonate. The only thing that we need to worry about is how much of the water are we going to add to complete this reaction. In order to get there, our next step is to determine how much of the potassium sodium tartrate is produced. And the potassium sodium tartrate is just the name of the Rochelle salt without the 4 waters of hydration. In order to do this, we're going to start with the 21.93 grams of cream of tartar. Convert the grams into moles, and we'll say every 1 mole of cream of tartar weighs 188 grams. Then we continue. According to the balanced chemical equation, every time we consume 2 moles of our cream of tartar, we produce 2 moles of our Rochelle salt. And then finally, we say that each mole of our Rochelle salt weighs 210 grams. From here, we find that if our reaction went to completion, we would have 24.50 grams of the potassium sodium tartrate. And in case you are wondering why is this the order in which we place the elements in this compound, it's because according to the UPAC rules, we place the cations in alphabetical order. The P from potassium is before the S from sodium, and so it's potassium sodium tartrate. Let's continue. While in the chemical reaction that is occurring between the cream of tartar and the sodium carbonate, what we produce is the potassium sodium tartrate dissolved. So we will have potassium ions and sodium ions and tartrate ions in solution, all of which will be surrounded by water, and that is why we mark it with aqueous. But as the water will slowly evaporate and the crystals of Rochelle salt will begin to grow, what we're going to grow is not just going to be the potassium sodium tartrate, but the potassium sodium tartrate tetrahydrate crystals. So let's calculate the mass of the crystals that we could grow. We find that we had 24.50 grams of our potassium sodium tartrate. First, we convert from grams to moles. 1 mole of the potassium sodium tartrate weighs 210 grams. From there, every time 1 mole of the potassium sodium tartrate crystallizes out of the solution, it will produce 1 mole of potassium sodium tartrate tetrahydrate solid. And then each 1 mole of our solid potassium sodium tartrate tetrahydrate weighs 282 grams. And we get 32.9 grams of our Rochelle salt, which is the potassium sodium tartrate tetrahydrate. This is where it's really important that we look up the solubility of the Rochelle salt in water, and we find that it's really high. According to my sources, it is 63 grams in 100 milliliters of water. So if we know that we need to dissolve 32.9 grams of Rochelle salt, then we're going to put 63 grams on the bottom and 100 milliliters of water on the top. This way, the grams of Rochelle salt cancel out, And we're going to have milliliters of water as our answer. And the number is 52.2 milliliters. I think we have all the pieces that we need. So for our synthesis, we needed mass of cream of tartar crystals. This we determined by measuring, using a scale, how much cream of tartar we recrystallized in our previous experiment. Cream of tartar crystals had a mass of 21.93 grams. Our calculated mass for the sodium carbonate needed is 6.18 grams. The mass of potassium sodium tartrate tetrahydrate that formed is 32.9 grams. This is what we're expecting. The solubility of Rochelle salt at room temperature, this is what we look up from our source. That is 63 grams in 100 milliliters of water. And then finally, the volume of water needed to dissolve all this Rochelle salt is 52.2 milliliters. From this information, we can derive our experimental protocol. And it could be something like this. Take a 52, maybe a little bit more, just in case there was a rounding error somewhere, maybe 53 or 54 milliliter volume of water. Pour it in a beaker. Add to this all your cream of tartar crystals. Weigh into this 6.18 grams of sodium carbonate and stir until you get a clear solution. At that point, add a lid or something to slow down the rate of evaporation of water and wait until crystals of Rochelle salt form.